It is generally considered unprofessional for a consultant to offer expert opinions on subjects they do not fully understand. The scenario described suggests a lack of fundamental knowledge of power quality. Consultants are expected to possess a thorough understanding of their area of expertise and provide well-informed advice based on that knowledge. Distributing such an email without further context or explanation could potentially damage the credibility of the organization involved. It is important for organizations to verify that the consultants they hire are both qualified and knowledgeable in the areas they are consulting on. Power quality is a broad term encompassing various aspects of an electrical power system that can affect the performance of sensitive equipment. Common power quality issues include voltage sags, voltage swells, harmonics, transients, and frequency variations. Voltage sags are short-term reductions in voltage, typically lasting from a few cycles to a few seconds. They can be caused by starting large motors switching on heavy loads, or by faults in the power system. Voltage swells are short-term increases in voltage, also typically lasting from a few cycles to a few seconds. They can be caused by switching off large loads or by faults on the power system. Harmonics are distortions of the sinusoidal voltage or current waveform. They are caused by nonlinear loads such as electronic devices, variable speed drives, and arc furnaces. Harmonics can cause overheating of equipment, nuisance tripping of circuit breakers, and interference with communication systems. Transients are very short duration, high voltage spikes or dips. They can be caused by lightning strikes, switching of electrical equipment, or electrostatic discharge. Transients can damage sensitive electronic equipment. Frequency variations are deviations from the nominal power system frequency, which is typically 60 Hz in North America. Frequency variations can be caused by imbalances between generation and load. Maintaining good power quality is essential for the reliable operation of electrical equipment, especially sensitive electronic devices. Poor power quality can lead to equipment malfunction, data loss, and reduced equipment lifespan. To ensure good power quality, it is important to identify and mitigate potential power quality problems. This can be achieved through power quality monitoring, harmonic analysis, and the implementation of appropriate mitigation techniques. Power quality monitoring involves the use of specialized instruments to measure voltage, current, frequency, and other power system parameters. This data can be used to identify power quality problems and to track the effectiveness of mitigation efforts. Harmonic analysis is used to determine the magnitude and frequency of harmonic currents and voltages. This information can be used to identify the sources of harmonics and to design filters to mitigate their effects. Mitigation techniques for power quality problems include the use of surge suppressors, voltage regulators, harmonic filters, and uninterruptible power supplies. Surge suppressors are used to protect equipment from voltage transients. Voltage regulators are used to maintain a stable voltage supply. Harmonic filters are used to reduce harmonic currents and voltages. Uninterruptible power supplies are used to provide backup power in the event of a power outage. Understanding the fundamentals of power quality is crucial for consultants and other professionals involved in the design, installation, and maintenance of electrical systems. A consultant should have a solid foundation in electrical engineering principles, including circuit analysis, power system fundamentals, and power quality standards. They should also be familiar with various power quality monitoring and mitigation techniques. A consultant lacking these basic understandings might misdiagnose power quality problems or recommend inappropriate solutions, potentially leading to further equipment damage or operational disruptions. A responsible consultant would openly acknowledge their limitations and seek assistance from qualified experts when faced with unfamiliar challenges. This collaborative approach ensures that clients receive the most accurate and effective advice possible. Electrical safety is paramount in all aspects of electrical work, including power quality investigations and mitigation. Only qualified and licensed electricians or electrical engineers should perform electrical work. It is essential to follow all applicable electrical codes and safety standards to prevent electrical shock, fire, and other hazards. The National Electrical Code, or NEC, provides comprehensive guidelines for safe electrical installations. It covers various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and equipment installation. Adherence to the NEC is essential for ensuring the safety of people and property. Article 100 of the NEC defines terms. Article 110 covers requirements for electrical installations. Chapter 2 covers wiring protection and methods. Article 210 covers branch circuits. Article 215 covers feeders. Article 220 covers branch circuit, feeder, and service calculations. Article 230 covers services. Article 250 covers grounding and bonding. Article 280 covers surge arresters. Article 285 covers transient voltage surge suppressors, TVSSs. Article 300 covers general wiring methods. Article 310 covers conductors for general wiring. Article 314 covers outlet, device, pull, and junction boxes, conduit bodice fittings, and handle enclosures. Article 320 covers armored cable, type AC. Article 330 covers metal-clad cable, type MC. Article 334 covers non-metallic sheet cable, types NM, NMC, and NMS. Article 338 covers service entrance cable, types SC in use. Article 340 covers underground feeder and branch circuit cable, type UF. Article 344 covers rigid metal conduit, RMC. Article 348 covers intermediate metal conduit, IMC. Article 350 covers flexible metal conduit, FMC. Article 352 covers rigid polyvinyl chloride conduit, PVC. Article 356 covers liquidite flexible non-metallic conduit, LFNC. Article 358 covers electrical metallic tubing, EMT. Article 360 covers flexible metallic tubing, FMT. Article 362 covers electrical non-metallic tubing, ENT. Article 366 covers auxiliary gutters. Article 368 covers busways. Article 370 covers cable trays. Article 376 covers metal wireways. Article 378 covers non-metallic wireways. Article 380 covers switches. Article 382 covers multi-outlet assemblies. Article 384 covers switchboards and panel boards. Article 386 covers surface metal raceways. Article 388 covers surface non-metallic raceways. Article 390 covers underfloor raceways. Article 392 covers cable trays. Article 393 covers low-voltage suspended ceiling power distribution systems. Article 394 covers concealed knob and tube wiring. Article 396 covers messenger-supported wiring. Article 398 covers open wiring on insulators. Article 399 covers outside overhead conductor spacings. Article 400 covers flexible cords and cables. Article 402 covers fixture wires. Article 404 covers switches. Article 406 covers receptacles, cord connectors, and attachment plugs, caps. Article 408 covers switchboards and panel boards. Article 409 covers industrial control panels. Article 410 covers luminaires, lamp holders, and lamps. Article 411 covers lighting systems operating at 30 volts or less. Article 422 covers appliances. Article 424 covers fixed electric space heating equipment. Article 426 covers fixed outdoor electric de-icing and snow melting equipment. Article 427 covers fixed electric heating equipment for pipelines and vessels. Article 430 covers motors, motor circuits, and controllers. Article 430.52 provides guidelines for motor overcurrent protection. Article 440 covers air conditioning and refrigerating equipment. Article 445 covers generators. Article 445.13 provides guidelines for generator overcurrent protection. Article 450 covers transformers and transformer volts. Article 450.3 provides requirements for transformer overcurrent protection. Article 455 covers phase converters. Article 460 covers capacitors. Article 470 covers resistors and reactors. Article 480 covers storage batteries. Article 490 covers equipment over 600 volts, nominal. Article 500 covers hazardous classified locations. Article 501 covers Class I locations. Article 502 covers Class Roman II locations. Article 503 covers Class Roman III locations. Article 504 covers intrinsically safe systems. Article 505 covers Zone 0, Zone 1, and Zone 2 locations. Article 506 covers Zone 20, Zone 21, and Zone 22 locations. Article 510 covers hazardous classified locations specific. Article 511 covers commercial garages, repair and storage. Article 513 covers aircraft hangars. Article 514 covers motor fuel dispensing facilities. Article 515 covers bulk storage plants. Article 516 covers finishing processes. Article 517 covers healthcare facilities. Article 518 covers places of assembly. Article 520 covers theaters, audience areas of motion picture and television studios, and similar locations. Article 522 covers control systems for permanently installed lighting. Article 525 covers carnivals, circuses, fairs, and similar events. Article 530 covers motion picture and television studios and similar locations. Article 540 covers motion picture projection rooms. Article 545 covers manufactured buildings. Article 547 covers agricultural buildings. Article 550 covers mobile homes, manufactured homes, and mobile home parks. Article 551 covers recreational vehicles and recreational vehicle parks. Article 552 covers park trailers. Article 553 covers floating buildings. Article 555 covers marinas and boatyards. Article 590 covers temporary installations. Article 600 covers electric signs and outline lighting. Article 604 covers manufactured wiring systems. Article 605 covers office furnishings. Article 610 covers cranes and hoists. Article 620 covers elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chair lifts. Article 625 covers electric vehicle charging systems. Article 626 covers inter-system bonding termination. Article 630 covers electric welders. Article 640 covers audio signal processing, amplification, and reproduction equipment. Article 645 covers information technology equipment. Article 646 covers prefabricated data centers. Article 647 covers sensitive electronic equipment. Article 650 covers pipe organs. Article 660 covers X-ray equipment. Article 665 covers induction and dielectric heating equipment. Article 668 covers electrolytic cells. Article 669 covers electroplating. Article 670 covers industrial machinery. Article 675 covers electrically driven or controlled irrigation machines. Article 680 covers swimming pools, fountains, and similar installations. Article 682 covers natural and artificially made bodies of water. Article 685 covers integrated electrical systems. Article 690 covers solar photovoltaic PV systems. Article 691 covers large-scale photovoltaic PV electric power production facility. Article 692 covers fuel cell systems. Article 694 covers wind electric systems. Article 695 covers fire pumps. Article 700 covers emergency systems. Article 701 covers legally required standby systems. Article 702 covers optional standby systems. Article 705 covers interconnected electric power production sources. Article 708 covers critical operations power systems (COPS). Article 710 covers over 600 volts, nominal general. Article 720 covers circuits and equipment operating at less than 50 volts. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. Article 727 covers instrumentation tray cable type ITC. Article 760 covers fire alarm systems. Article 770 covers optical fiber cables and raceways. Article 800 covers communications circuits. Article 805 covers communications systems. Article 810 covers radio and television equipment. Article 820 covers community antenna television and radio distribution systems. Article 830 covers network-powered broadband communications systems. Article 840 covers premises-powered broadband communications systems. Article 900 covers tables and examples. Table 310.15b16 provides ampacities of insulated conductors rated up to and including 2000 volts. Table 310.15b17 provides ampacities of insulated conductors rated up to and including 2000 volts when 3 or more current-carrying conductors are installed in a raceway or cable or are directly buried in the earth. Table 310.15b18 provides adjustment factors for more than 3 current-carrying conductors in a raceway or cable. Table 310.15b21 provides adjustment factors for ambient temperature. Table 310.15b3a provides allowable ampacities of single insulated conductors rated 0 through 2000 volts in free air based on ambient air temperature of 30 degrees Celsius. Table 310.15b3b provides allowable ampacities of 3 single insulated conductors rated 0 through 2000 volts in a raceway or cable or directly buried in the earth based on ambient earth temperature of 20 degrees Celsius. Table 310.15b6 provides conduit or tubing fill permitted for conductors. The NEC provides essential guidance for safe and compliant electrical installations. It is recommended that the NEC be consulted and followed.